and welcome back to Special Ed on Special Ed. I'm your host, Dana Jonson, and today I have Dr. Kyle Daigle, who is an expert in neurological rehabilitation and child development. Dr. Daigle is not your average chiropractor. He has a fellowship in childhood developmental and neurobehavioral disorders, and he's changing the game in healthcare. As the co-owner of NeuroSolution, a pioneering therapy distribution and educational company specializing in photobiomodulation and neurological rehab equipment, he's at the forefront of cutting-edge wellness. He also has a book out, The Cracking the Code of Autism. But that's not all that Dr. Daigle does. He is also the co-inventor of NeuroSage, a revolutionary computer video game that harnesses targeted auditory and visual stimulus to boost overall wellness. He's a former college athlete, and his passion for health and wellness extends to lecturing all around the world on topics like traumatic brain injuries, spinal cord injuries, mold exposure, and childhood development. And I am really happy to have you on today, Dr. Daigle. Thank you for joining me.
Thank you, Dan.
Before we get started, I do have to play my disclaimer because I'm a lawyer. Can't do anything without my disclaimer. Anyway, here goes my disclaimer. The information in this podcast is provided for general informational and entertainment purposes only and may not reflect the current law in your jurisdiction at the time you're listening. Nothing in this episode creates an attorney-client relationship, nor is it legal advice. Do not act or refrain from acting on the basis of any information included in or accessible through this episode without seeking appropriate legal or other professional advice on the particular facts and circumstances at issue from a lawyer or service provider licensed in your state, country, or other appropriate licensing jurisdiction. Hi, I am so glad you are here. I'm really interested in discussing a lot of what you're doing, especially the photobiomodulation, which I'm so impressed I said correct, right as I went through it. I was really impressed with myself because there's a lot of letters there. Anyway, but I'd like to start with just your background and, how you came to be this expert in child development. I'd like to talk about how you got to be here and why you're here talking to me. So give me some of your background.
All right. So it started out actually my middle brother. We were actually just in a car, just had a medical procedure, both of us. And my mom were driving. And all of a sudden, I look to the right side and my brother is having a seizure. And I'm screaming for my mom. My mom turns around. My brother's like seizing out, turns blue. She's in this little Honda Civic, literally makes a U-turn on the interstate and goes through the median straight to the hospital. And my brother actually ended up getting meningitis following from this procedure. And so I watched my brother for 6 straight weeks in and out of ice baths, almost dying. And I remember to this day, because this was the most pivotal part of my life, is that whenever the doctor walked in and told my mom and dad that your little son is going to be okay and he's going to make it. And I watched my dad literally hold this doctor. His name was Dr. Wallace. And he just screamed. He would just squeeze and wouldn't let him go. And I watched that and I was like, I want to be that guy one day. So I actually had a lot of sicknesses as a child, really bad allergies. I had asthma, I had ADHD. I was medicated for 18 years up until I actually was undergrad and I actually started doing research. And I got exposed to nutrition and believe it or not, that I actually started reading about food sensitivities, got off of drinking milk. I completely no longer have had to use an albuterol pump and a daily allergy shot. And I'm actually off of my methamphetamine medications by altering my diet. So that made me basically really start looking into biochemistry. And in the pursuit of biochemistry, vitamin and minerals run all of our chemical systems in our body. And my personal opinion is that we're not treated from a basically nutritional deficiency standpoint. So then I had to figure out alternative means into not going the traditional route as being a medical doctor. And that led me into actually being a chiropractor. And the reason why I wanted to be a chiropractor was because at the time when I was in undergrad, physical therapists did not have direct access to the general public. You can actually have to go to be a chiropractor and, chiropractors you can have direct access. So in the mix of that, I really fell in love with the brain and I really wanted to work on how the brain and nutrition worked. And then my background, I met a doctor named Dr. Brandon Brock, who really kind of highlighted traumatic brain injury rehab to me and vagus nerve stimulation. And then I really wanted to kind of figure out how to fix my ADHD. So then I started reading books on childhood development, primitive reflexes. And then I came across an incredible mentor of mine, Dr. Robert Malilo, who wrote a book called Disconnected Kids. I actually started doing primitive reflex integration work on myself, and it was completely life-changing. And then boom, that basically led me into a background in nutrition from a personal standpoint, studying the nervous system in chiropractic school, but then actually studying traumatic brain injuries and then looking into primitive reflexes. That then brought me to really a crazy fascination to, have a very kind of wide demographic of patients. But that in the, long roundabout is how I got to where I'm at today.
I'm fascinated by the brain as well, and I'm always interested it's always evolving. And I was a psychology major in undergrad, which was a million years ago, but I love all the studies that have been coming out, and particularly in neurobiology and neuroscience. It's really riveting to me. Now that we know I can say photobiomodulation, I'm not sure I know exactly what it is. So could you talk a little bit about what it is? I know the acronym is PVM. And how does that work in neurological rehabilitation?
Yeah. Okay. So when you really break the word down, in medical terminology, the words are always really, really long. So photo broken down means light, bio means life, and then modulation is changing. So basically, photobiomodulation means changing life with light. So really, in a very simplistic way, photobiomodulation is basically light therapy. What really got me into photobiomodulation was actually looking into studying physics. Okay. And Albert Einstein came up with this amazing equation, E equals mc squared, right? Energy equals mass times c squared, the speed of light. And because of my ADD as a child, or ADHD, what happened is I always wanted to know the answer to why to everything. So that equation really stuck out to me. And so then what happened is I broke it down into very simplistic terms. Energy equals mass, but mass times every single cell in the entire body and every atom, times not just light, but the variation of all the colors. And when I look at a human being, we're really predominantly exposed to really one predominant color, and it's actually blue. Because we live indoors, we're in front of computer screens all day long. And so what happens is if the light exposure is only one color, and we don't get exposed to all the other variations of color from the spectrum, then what happens is our energy levels can be altered. We can either see, like ADHD and autistic kids, a lot of hyperactivity, or you can even see people who have like chronic viral infections have really, really low energy. And so when you really look at a lot of these kids on the spectrum, they're exposed to iPads and tablets. They don't really typically gravitate to go outside and ride a bicycle and play outside in the sun. And so when you break that E equals mc squared, they're only really exposed to about 90% of blue light. And you can actually, photobiomodulation, you can literally change or modulate light exposure with light. And that's one of the amazing things about what I do is I use a lot of red and also violet light, which are colors that these kids and even patients aren't really being exposed to. And so it's very interesting that when someone starts looking at benefits of variations of colors, is that different colors have different benefits. And the actual color red is shown to have crazy, crazy benefits. Red light can act as an anti-inflammatory, which a lot of kids on the spectrum have a lot of inflammation, specifically in their GI system and also in their sinuses. Also, red light therapy does something called vasodilation. It can actually improve blood flow. And if you improve blood flow, you can actually improve function. And when you basically, red light also activates something called mitochondria, which are actually these little bitty cells in the body that produce energy. And then also red light therapy is phenomenal for just basically even helping out with sleep. So, God basically made the sun for something called a circadian rhythm. So basically, literally sunlight or sunrise and sunsets, that light exposure to the back of the eye actually calibrates your circadian rhythm, your sleep cycle, which is why people who, like myself, I go work in the Middle East. And if I don't get proper sunlight, I could actually have jet lag and have sleep disturbances. And so what's happening is kids, especially on the spectrum, They're not waking up watching sunrises and sunsets, and they're being
Right.
exposed to TV all the time and from monitors and cell phone. So if they're not actually using something that scientifically, meaning the circadian rhythm, our bodies are designed based off of the light cycle, and they're not getting exposed to that, that can have implications. For example, carbohydrate metabolism. These kids don't break down
Huh.
carbs because they eat carbs like crazy: buttery noodles, crackers, pizza, chips. The other aspect of that stuff is these kids typically have what's called high beta waves, and the brain functions off of brain waves. So that's one interesting thing, that, sleep restoration is actually done from light exposure. And so the only way to basically induce that is by actually using light. And we use photobiomodulation to help out with these kids on the spectrum or even other developmental delays.
Wow, that is really interesting. And so I guess that, as you said, they're not getting up and looking at sunsets and sunrises. So, presumably for kids who get up in the dark and go to school and they're in a classroom all day, if they don't, can you get enough of that if you're in a classroom with a window, or does it really need to be outside? 'Cause I know my doctor told me that I should go outside and sit in the sun for 15 minutes a day, regardless. I'm in Connecticut, so we don't always have sun, but then we should go outside and be outside for 15 minutes.
Correct. I would
So,
completely 100% support that, doctor, because what's really interesting is when you start running CBC, so basically blood draws on these kids, they actually have low vitamin D. And if you look at like autism and vitamin D, there's a high correlation to that. Where do you get vitamin
right.
D? From the sun. And
Sure.
that's very interesting. Also get it from a food source that, these kids don't eat the foods like fish that promote that. And then the other interesting thing is, just to and basically ask you this question, is if you go to the beach, what happens is you feel amazing.
Hmm.
What happens is the sun actually can release something called beta endorphins, which actually make you feel good. And the other aspect is that people who get sick, who actually literally go on a vacation to the beach and they're outside in the sun, guess what happens to their energy and their infections and stuff? Their energy levels go up and they actually start to feel better. Well, vitamin D is produced from the sun. So if you're outside in the sun, you get this natural increase in your immune system. But there's another very interesting thing that got me, is that there was a study that was actually done in a village in Africa. And what they did is they actually did pre and post stool samples on these patients. And they gave this village people American food, candy bars, Fanta
Hmm.
sugar, all these highly carbohydrates. So when they did post stool analysis, they didn't see anything really change. There was no yeast overgrowth and inflammatory markers. And the doctors were astonished. But the answer to that was actually is that these people actually run around actually without shirts, and they're actually
Huh.
getting sunlight to the actual abdomen area. And in microbiology lab, we actually use violet light, UV light, to actually sanitize the actual desk that we're working with microorganisms. Well, guess what? Actually, the sun also produces a violet light, which is why we get UV exposure and we can even burn. So it's very interesting that we, in our practice, we basically substitute variations of light through photobiomodulation in red and violet light to actually help these kids basically overall comprehensively, get better from that little analogy.
And thank you for supporting my 1 week at the beach a year. So it's my favorite week of the year. And you're right, I feel amazing the entire time. So now I can justify it. That is just really, it makes sense. And now you were saying, the population that was studied, they run around with their shirts off, so they have their abdomen. So is it important that that light comes to the specific part of the body you're trying to address? Or, I have a light mask that I put on my face when I remember to charge it and use it. It's supposed to be good for, my anti-aging creams or whatever it is I'm using that week. So is that the same idea? I'm sure yours is a different level of what I'm using, but what kind of intake do people need for it to be effective?
My main thing is I use red light actually over really arteries. And when we look at the brain, for example, there's really two main blood supplies. We have our carotid artery right here in the front of our neck that's going to give blood flow to the front 2/3 of the brain. And then you actually have your vertebral artery, which runs behind the actual neck inside the spine. That's going to supply blood supply to the brainstem, which is what controls our organ functions, and then our vision and our parietal lobe, which is our map of our body. So I really like using red light exposure to the carotids and then also to the base of the neck, the back of the neck. And it's very interesting because if you ever use like a red light panel and you literally get in front of it, what happens is you might notice that your veins and arteries, they kind of surface to the skin because our veins and arteries have a receptor called a chromophore for light. So when you get exposed to red light, it actually causes vasodilation, which opens up blood flow and it gets better blood flow, better function. So I really
Wow.
like using the carotid arteries, the back of the neck for the vertebral arteries. A lot of these kids, especially on the spectrum, they actually have a lot of gastrointestinal inflammation. So I love to do a lot of red light actually over the whole stomach, the abdomen area. The next thing is the thoracic or the spine. Again, hence I am have a chiropractic degree, but the spine, which is actually where the nerves are going to also help supply, energy to organ functions. And then I like the hands, the feet, and then the face. And those are my very basic applications. So we have the neck, front of the neck, back of the neck, abdominal area, hands, bottom of the feet, face, and back. And then there's also something called transcranial photobiomodulation, big fancy word, but basically red light actually onto the scalp, which is actually, your scalp has a chromophore light receptor as well. But again, from a clinical speaking on something like this, unless someone's, a doctor, we typically stay, below the neck. So basically, those are my favorite applications.
That's fascinating. Is this the same kind of light? I'm sure it's different, but that like grow lights, like, when you get grow lights to do seedlings or something, that you have to do red or blue. Is that the same, or is it a totally different kind of light?
I'm not familiar with that.
Oh, okay.
Yeah, I'm not
I'm
familiar
always
with that.
trying to grow stuff. I can't. I'm horrible at growing things, but I'm always trying.
Our lights are, we predominantly use red. So we use LED and we have diodes. So we use we have those light panels. We sell those red panels as well as handheld lasers that are more specific and more, a little bit more powerful than these red light panels.
What kind of exposure is necessary to make a difference? Like if I'm talking about, so my face thing that I have, it's just on my face. Is this an ongoing thing? Is it something that has to happen repetitively? And is it, do the kids spend a day with you or an hour with you? How does that work out?
Yeah, well, there's lots of ways. I think that, go back to what your doctor mentioned about being outside in the sun for 10 to 15 minutes. And because of kids are in school, the weather changes and stuff like that, maybe not time of the year not being outside in the sun. So I typically at least recommend anywhere between 10 and 15, 20 minutes, at least of daily use of red light exposure.
Mm-hmm.
My clinic, I have a very hierarchy of how I treat patients. So we have patients that come in and do therapy for like an hour. And so those patients could probably get red light for about 10 to 15 minutes. And then the way I really work is something called an intensive program where I'm actually working on kids for anywhere between 3 to 4 hours a day. And they're actually going to get quite a bit of red light exposure, a little bit more than 15, 20 minutes. But really, I base a lot of red light exposure based off of running stool samples and blood work by actually looking at stuff like C-reactive protein, ESR, homocysteine, inflammatory markers, and then looking at stool samples, looking at like caloprotectin, different, basically looking at, their inflammatory. So the more inflammation that someone has, the more red light therapy that we actually use. So it's really kind of based off of like a per patient case. But in an average, for everyone listening, at least anywhere between 10 and 15 minutes, just like your doctor mentioned, of red light exposure.
Interesting. Do you work with other lights or do you primarily just red?
Red and violet.
Red and violet. All right. You mentioned the violet. That's fascinating.
Red, violet, and then I use blue on a lot of patients with spasticity. So people who maybe have Parkinson's or someone who maybe had a stroke or something or TBI. Those are my three colors. And then green, we use green as well. So, but I typically red, violet, and a little bit of blue and a little bit of green. Okay.
Interesting. And what does the green do?
Green can actually help out with like fat metabolism. Yeah. But I mean, green, yes. It's wild to start seeing what all these different colors can actually do. And then blue, I've used blue for like muscle activation.
Oh, wow. No, it really is fascinating. I mean, I really haven't thought about it other than I have this mask that I put on and it's got light and I know it's good for me and that's about it. And my doctor said to sit outside 15 minutes a day. So what's the science behind this? Is there science behind this? Is it backed by peer-reviewed studies? Is this something that is legit, for lack of a better term?
Yeah, no, there's a lot. There's if you go type in, because the thing, if you type in like red light therapy, it's not really going to pop up for your scientific journals. However,
Right.
photobiomodulation. So really, if you go to Google or you go to like with doctors, we're going to look at PubMed. So in PubMed, you're going to type in photobiomodulation and autism, photobiomodulation and TBIs, photobiomodulation and spinal cord injuries. And there's a lot of studies with, anti-inflammatories, helping to boost the immune function, helping out with perception, helping out with mood. I mean, yes, sleep, insomnia. There's a lot, but you have to type in photobiomodulation and the benefits. And then also to answer the other question too, but even like green light. So green light also has helped with patients with like weight loss. It also is an anti-inflammatory. Blue light has been shown to actually increase alertness. So you have patients that, for example, like if you get in front of a screen like this right here, blue light exposure can actually like wake you up. So alertness.
Oh, so that's why they say not to be on your screens before you go to bed because of the blue light. That makes sense.
Correct. Yeah, and really it's pretty neat. So in the back of the retina, we have something called amacrine cells, which can actually be stimulated by light exposure. So there's a lot of research now that's actually going to color therapy. Like, for example, there's color glasses. There's a whole technique out there, even called Erling lenses, where people literally like with dyslexia can put on like pink glasses or red glasses and the kids don't have the letters, backwards.
That's
So
fascinating.
actually coming from color lenses.
That is fascinating.
Very fascinating.
I never heard about that for dyslexia, but that's something I have to look into. So it's just the color of the lens impacts how you view it, how your retina responds to the stimuli.
It's insane. I mean, I literally do this all the time. When I actually do my evaluation, I do it with a pulse ox and I literally have different colors and I'll try different colored glasses and I can actually watch someone's heart rate actually calm down by literally using the light to the actual colored glasses to the eyes.
Oh my gosh, that's fascinating. That's really interesting. So what is NeuroSage? What is that?
Yeah, so NeuroSage was a computer software program that I helped co-develop. And really what happened is it really came from observing kids on the spectrum because these kids would actually come to see me and the parents would always mention, they're like, yeah, I just like can't get my kid off of the tablet. He's always on YouTube watching the same thing.
I'm familiar with that concept, yes.
And so really what I was doing is I was like looking at these kids and I was thinking, well, what if I basically made a computer software program that would actually use colors, basically in the form of visual, and then also auditory, because the brain likes different things. For example, like the right side of the brain, which calms kids down, deals with their posture regulation and suppresses involuntary movements, typically has more of like a, stimulation to blues and greens. And then you see the left frontal lobe, which is going to deal with like your speech centers or activation, memory, math, science, has been shown to respond from red and yellow. And so I was like, what if I can basically start making video games based off of, colors in rhythmic music? Because there's different frequencies or different sounds. Like, for example, melodic music can activate the right side of the brain to be calming, which is why they use interactive metronomes to help calm kids down with anxiety versus techno, fast fading music, which is going to activate the left frontal lobe. And then there's eye movements. So, for example, in stroke rehab, someone has a stroke and it's on the right side of the brain, the parietal lobe, they can't track to the right because the function of that actually deals with eye movements to the right. Or something, saccade, which are quick, fast eye movements deal with the frontal lobe. And so really, I took neuroscience and basically put it into actually video games by using color, sound, and eye movements, and then a reward system. And then that right there was basically, now I can get an autistic child that now wants to come do therapy because he's actually playing video games that he loves. So I'm using that initial sensory stimulation, which is a reward system to that kid, to then now get his brain stimulated, and then I can get him to start doing therapy.
Oh, that's interesting. Yeah, because I mean, you're right. I mean, the video games, I have a lot of children, and so the video games are always the issue. And I remember my daughter did neurofeedback, and that was watching a movie. It was like the only thing that could get her to sit still for 2 minutes, and did that. I mean, which is not light based, but it's, you know, the same kind of concept, I guess, of addressing the brain and manipulating the brain function.
Totally.
What was I just had a question. Oh, and then with trauma, I think what you just said about the eye movements, I know there's some kind of therapy related to the eye movements for trauma. Is there a light equivalency to that?
EDMR. So EDMR.
EDMR, yes.
EDMR. So there's a lot of eye movements. It's very interesting that, I work with a lot of special force guys, Navy SEALs, Green Berets, combat divers, and especially who are in the war, and they come and see me, and we actually literally have our patients do video games. But it's very interesting because horizontal eye movements actually help stimulate a part of the brain called the pons, which actually releases serotonin. So serotonin is a mood relaxation, and it's also converted to melatonin for sleep. Then you have vertical eye movements, which activate the midbrain, which is what's going to pump out dopamine. That's why people like to scroll on their cell phone and they get lost in doing that because they just get a dopamine rush. So you can actually use eye movements to stimulate different parts of the brain. And then again, you layer it in with like colors and sound, and then you can start getting more precise. And I brought in a bunch of team members. So Dr. Robert Belilo, who published This to the Kids, he has a textbook over childhood development. Dr. Brandon Brock, who's a traumatic brain injury specialist. Mm-hmm. And then I brought a whole software team of actually computer programmers and AI guys. And we just basically literally got into a room and nerded out. And then we basically video games for really a lot of, they're considered wellness because again, they're not like FDA approved video games, but they're a sensory experience where they're games designed to basically help enhance overall wellness.
I think every parent should have a course on how the phones actually, or the devices actually suck kids in. I did look at that. I have 5 children. At some point, I remember looking through like, what are the things? And I like to read. I'm a nerd. I like to nerd out on things like this. And I remember, the certain colors that they're used that draw you in to certain pages or that keep you on them, and how the psychology behind it. So it's fascinating to take that sort of the psychology component, add it to the neurobiological component, and put it together into a game that provides the benefits of that light therapy.
No, the answer to that is actually, for people that are listening, is actually called neuroaesthetics. And if you type in neuroaesthetics, it's going to actually talk about the colors and the influence of what it can do from a behavioral standpoint to, lots of stuff. But neuroaesthetics is for people that
neuroaesthetics.
Neuroaesthetics.
And I'm thinking, because you've talked a lot about autism, and I'm also thinking kids with ADHD, that would impact for them as well, because it seems that the neuroaesthetics, as you said, riles them up to some degree, right? If you have ADHD. So what is it, the same therapies that you use for children with autism that you would use for a kid with ADHD, or would that change how you do the light therapy, or what color you would use?
Really, the way that I actually physically treat patients, especially kids, is that if I can, I actually do what's called QEEGs. So similar to the neurofeedback you're talking about, I actually do a full brainwave assessment to actually look at all the different variations of brainwaves and the different activity within the Brodmann areas, so the networks within the brain. And then I do what's called a cranial nerve assessment, because sensory input from the environment drives brain development. And so what I do is actually figure out exactly, what the sensory deficits are, the pupil size, how well the eyes move, can kids smell out of both nostrils, their facial tone. Like I just had a kid earlier who couldn't even do a right facial contraction. And then I actually look at something called the vagus nerve function. And then, I put together a plan based off of their brain function. So I might have kids do like 10 minutes of a certain color, 5 minutes of another. And then we have generalized, which is my patients go home with NeuroSage Home, which is actually the video games. And so what they do is I have like standard things, for example, just overall wellness, which has like all the different colors. But predominantly, like kids with dyslexia, that's another thing. So dyslexia, it's very interesting that it's clinically speaking here, that
Sure.
if we actually use like red glasses and then we have kids basically playing our video games that basically have sound just coming out of the right ear, which stimulates the left frontal lobe, which is actually where like reading and letters and stuff are at, those kids actually read better. So what we have parents do is they basically play one of our video games. So let's say, for example, we want to stimulate the left frontal lobe. So we have video games that you literally select the brain, and you can either put to the left and it'll light up like the left side of the brain, or to the right. And so, yeah, they'll basically literally play these left brain games, which is going to be sound coming out of the right ear, and then all these like red and yellow. And the goal is to use this auditory and visual to stimulate the left side of the brain. And then these kids try to read and do homework after that. And we've seen a pretty good retention or enhancement in cognitive scores, or even, memorization. And you take like these children who are on the spectrum, who basically have a lot of stimming, they have, aggressive behavior, impulsivity. We'll do a lot of like right brain games, which is going to be sound coming out of the left ear, and lots of blues and greens. And that has been clinically shown to actually help these kids with, self-regulation, less stimming. And then you get like ADHD, because there's variations of ADHD. There's a
Right.
hyperactivity, which is typically a lot of underactive in the right frontal lobe based off of, QEEG assessments. And then you have the learning disabilities, which is where these kids have issues with memory retention. They just can't seem to get it, which is typically underactivity in the left frontal lobe. And then we can quantify this from actually looking at, EEGs and electrical activity and brainwaves networks in the brain.
And how lasting is this? Because I do remember when my daughter did, it was a million years ago when she did the neurofeedback, but it was fascinating to see the actual changes. You could see it light up. And I presume that's the same picture. I don't know the technical term, but the pictures of the brains where areas light up. And so how long do children retain those benefits? Is there a long-term goal, or is it just something they're doing forever?
Yeah, well, it kind of goes back to, I think that really, parents, especially listening, should really ask the question, why, what's really going on? Because inflammation is a huge thing. Because inflammation is going to basically cause irritation or prevent, the brain or, different networks from really turning on. So that's one thing. Diet makes a significant, change, although it's not the easiest thing, because kids, aren't too compliant to wanting to eat healthy foods. And then there's something called the MTHFR, which obviously, if you've done these enough, there's a genetic aspect of how well the brain's going to absorb B vitamins to make it build neurons and networks. So if you get a child on the spectrum who's like super severe, it's often typically recommended that we do 15, 20 minutes a day of this stimulation. Duration, super severe kids, they could be doing this stuff for 4 to 6 months, because what happens is the sensory input builds brain development. So in order to learn something, you can't just learn a new language. You have to practice it. You have to read it. You have to speak it. You have to hear it. You have to write it. That builds these networks in the brain. So for us, we're really just doing basically a small amount of 15 minutes is what our games actually last, just to try to build function of the brain. But because a lot of these kids have a lot of underactivity within their brain, they really need, really more than just this video game. The goal is to just use this as a sensory stimulus. So the lasting impacts, I can just give you an example. Like, we had a Parkinson's patient who came down and did treatment with us, and we were actually able to significantly reduce the tremor, and they only lasted up to 10 days. So it was basically 1 week of doing stimulation. So basically 15 minutes a day for 5 days. And then the carryover effect was 10 days after that. So NeuroStage, it's actually in like 145 different locations around the world. And yeah, I mean, a lot of these doctors are using it and seeing great benefits, but it's going to kind of go based off of those parameters. So inflammatory markers, nutritional aspect, methylation issues, which is nutritional supplementation of B vitamins, and then actually the health of the actual brain. So the more developed someone is, the less that you're going to actually see the lasting impact, because those neurons and networks in the brain are underactive.
Got it. But there is, in some situations, a lot. It's not like every single day and you're getting it. You're doing it now for just today. you see some lasting. So someone might do it for, like I say, Parkinson's, they might do it for a week and then come back a week later, or is that sort of the pattern?
Well, we made it like this, is that clinically, so we started this thing in December of 2013. So now we're going on basically over 10
Almost
years.
10 years, yeah.
Yeah, and it was really just based off of really, I wanted to see what would happen to my demographic of patients, clinically speaking. What happened is that after studying blue light exposure and all this stuff, that I really think that 15 minutes, 20 minutes a day is about, a good threshold for sensory stimulation from screens. So we made the video games based off of that. And really the goal for this was just to basically have someone play on a daily basis, which means that I built commercial platforms for all these clinics around the world. And then we got to the component and people are saying, look, can we get this into the homes of these kids? Because this is actually helping these kids self-regulate. So then I basically got my team together and said, hey, let's build a cloud-based software and let's actually get this stuff into the homes for these kids to do it on a daily basis. And really, that's really kind of NeuroSage has now kind of come to like a daily basis where now someone can actually download NeuroSage home and parents can actually use this on a daily basis with the kid, but it really is only designed for, 15, 20 minutes of daily usage. So yeah, it's just sensory experience.
Okay. And then, so with NeuroSage, is that include, because I might just be confused, but is that the light there? That's not the light therapy, or it is the light therapy? No,
Yes,
it's just the stimulate,
it's
ocular
and visual.
Auditory and visual. That's okay. So there's the auditory and visual component, and then the light therapy as well. So they complement each other. Is that, am I understanding that correctly? Got it. Sure. That's really interesting. And so you do the light component part then when people come to you physically and you determine how that works for them, right?
Yeah, so really it started that I started teaching all over the world, and I realized that these doctors really didn't have access, especially in Europe and Australia and the Middle East. They didn't really have access to being exposed to what we have in the United States. So what I did is my partner and I started a medical sales distribution company. So we actually started teaching, but then we would actually bring all the stuff we were using in our practice, red light, electrical stimulation. And then I had this software company that I was using. And so then we started teaching people basically how they can use video games and then how they can use light. And then we would teach them how to do the therapy. So that's how it kind of went into NeuroSage, computer software, Photobiomodulation, neural solution. And then we teach how to basically apply this stuff into therapy.
And that's definitely, I'm presuming the video game piece has really drawn your students would be really clients, however you say it, patients are very much drawn to that. So it sounds like that is a format that would work well for them to get them engaged like that.
Yeah, well, the whole thing is that it's a lot of teenagers don't want to go and do core exercises and stimulation versus you can tell me that I can play a video game and I can get benefits. And really the goal is to just basically start using sensory through the eyes and the ears to start stimulating and enhance the function of the brain. And then there needs to be additional stuff. For example, like you need to eventually do that. But in order to get a parent to bring their kid for therapy and the kid's not going to want to do core exercises, but at least getting them involved. And then now we actually have virtual reality, which then the kids really, older kids, teenagers really like virtual reality. So the goal here is to basically get these kids to come in and actually start doing therapy. But yeah, that's video games just significantly help out the retention of ADHD and autistic children, especially with the doctors that do therapy with us.
Amazing. So how would a parent determine or integrate these kinds of things into their child's life? If they have a child with ADHD or dyslexia or autism and they're thinking this sounds really great, like where do they start?
Yeah, well, in my book that I wrote, So Cracking the Code of Autism, I have like a whole thing about the progression of how to use these video games, because the video games were originally designed for my patients and then the doctors that I train, and they would basically distribute it out. But do I always tell people that we have a standard. So if someone downloads like NeuroSage Home, it's going to actually have a stock where you have to overwrite. It's going to actually go to where you just click A on the video games, and it's going to be beneficial for both sides of the brain. But then if you have a kid who's got dyslexia or severe developmental delays like under functioning, then you have to override the system and actually make it go to like the left side of the brain. So we always tell our clinics and our doctors, when in doubt, always go right, which means that you can never really get any negative benefit from actually stimulating the right side of the brain because that's calming, versus the left side of the brain is going to drive more energy, is going to drive more dopamine. So you don't want to really do that. So that's why the games were designed to where they just automatically populate to the right side of the brain. And then you have to override that to actually go to basically kind of enhance the function of the brain. That makes sense. So yeah, it was just
Yeah.
I really, because a lot of the doctors, when I start teaching, it's very interesting that teaching. And again, we have everything from medical doctors, PTs, OTs, DPTs, nurse practitioners, PAs, chiropractors. A lot of these doctors are like, look, I don't really know a lot about neuroscience. So we try to make this a lot easier for them. And then they would basically put their patients on this. And then now that we have this cloud-based software, the goal for us is to basically launch this completely globally as long as someone has access to the internet. But if you open the game up, it's automatically going to populate to the right side of the brain, which is going to be more calming and relaxing.
That makes sense. Do you find, does insurance cover this at all? Or is that like starting, or I know when things are newer, it's harder to get them covered.
Yeah. So right now, no, this is still, I guess, what consider as the insurance companies call this stuff pseudoscience.
Yeah.
Now there's actively stuff right now in the works of actually something with the FDA called digital drugs, where the FDA is actually working on trying to put together a board so that way they can actually start seeing if software applications can get the same benefits of clinical drugs. Our company, we've done a couple of IRB studies. We're working on actually eventually going after this, FDA procedure to get classified as a digital drug. Right now, it's just a sensory experience. No, insurance is not covering that. I do have some stuff I'm working with in a different country that the government is actually looking at our software to actually get this, applied through for mental health disorders. But here currently in the States, no, the FDA, we're not regulated or not. We're not basically under approval of the FDA.
Not yet.
Not yet. In the future, hopefully.
Yeah, hopefully. Do you see any schools embracing this, or is this not in that realm?
Yeah, no, we actually have, actually in the Northeast, I have a school district up in New York that we actually have this in the schools. We've used this in even certain populations of HR departments in the state of Texas.
Oh,
Yeah,
wow.
we haven't really marketed the product. It's basically been from lecturing and the people finding us online. But yeah, no, we're in schools. I'm opening up a facility in Dubai. We're going to get this stuff into the school systems in the Middle East. But yeah, no, it's pretty beneficial because a lot of these kids, like I said, if you have a behavioral child and you tell them to go sit in a corner and, write lines, that's not going to be beneficial. But if that kid actually literally got in trouble, he could play a video game, but the video game isn't beneficial, the kid's going to basically be more inclined to actually participate in that than writing lines.
So for the schools that you're seeing embrace it in the United States, are you seeing it as is that something that's an IEP based thing that they might put into it, or is it a complement to what they're already receiving? Because I would see that, because I would guess that there would be concern about actually putting that in an IEP from just a legal standpoint, because I'm a lawyer, so I think that way. But I would be the person arguing for it. But are the schools that have embraced it seeing progress?
It's a compliment, but we're doing this as of right now. So we're still under a research project to do this. And really what we're doing is we're actually using NeuroSage, and then we're also doing primitive reflex integration and core exercises. So primitive reflexes are infant reflexes that babies go through, like pattern movements, like crawling, sucking on a bottle to help with the rooting reflex. So like preventing kids from basically spitting up or even speaking. Hand stimulation for palmar grasp, Babinski on the foot. So there's basically these exercises that we have patients do for the moral reflex, which is the startle reflex. You drop something, someone gets startled. The palmar reflex for these nonverbal autistic children, if you stroke the hand's actually grasping like a baby, which is why they have poor immaturity in their hand. Same thing goes to the foot. The Babinski, if you stroke the foot, the toes are actually supposed to curl down. What's happening in these children when you do that, they're basically fraying up. which is basically meaning the reflex is still there. And then a lot of these kids with developmental delays didn't crawl properly. They scooted. Maybe they crawled with one arm kind of bent or didn't crawl at all. And you crawl before you walk. And there's patterns for that. So there's exercises called the lizard. But yeah, so basically the primitive reflexes, which I wrote in my book, is it's all these pattern movements that the brain goes through. And what it does is it allows the brain to mature. And what you're seeing is if you Google, primitive reflexes and dyslexia, you're going to see that 50% of kids with dyslexia actually have the asymmetric tongue and neck reflex. Then you look at nonverbal autistic children, you're going to see that they actually have the Moro reflex, the AT&R reflex, the palmar, the rooting, and then the spinal galant. And then you look at ADHD, you'll typically see that maybe they have the AT&R reflex, maybe the rooting reflex, and the kids who bedwet have the spinal galant. So it's very interesting that these reflexes are designed to basically help with brain development. So if these kids don't integrate these reflexes, what happens is you start getting overcompensation in the brain, hyperactive networks and underactive networks. And that basically is why you get an autistic kid who's like, crazy smart. He can like memorize all these numbers, but then he can't self-regulate. And it's because he's got hyperactivity on one side and underactivity on the other. And the whole goal is as these reflexes integrate, it allows the brain to basically, cohesively start working together. And that's what, ADHD is. It's basically hyperactivity within the brain. The brain's not fully integrating to basically work together.
Right. There's so much information here. I'm like still processing. I'm going to have to listen back to this multiple times. So where do you see this headed? The neurological rehabilitation, like where is this photobiomodulation taking us?
Well, I see this from my perspective that what we're currently doing is, believe it or not, we're actually going out of the United States. And we're going out of there because it's way more accepted outside, especially in the Middle East. So we're actually having government meetings, which is very interesting. That what I see this happening, hopefully, is that we go to the Middle East and we really, for the next 5 years, we really help change the basically healthcare system in the Middle East. And then here in America is basically going to be watching what's going to be going on. And then we basically bring this into the hospital system and the universities here after we get about 5 years worth of, bigger clinical data, way more research. But yeah, I think that, Russia is very interesting because Russia is where a lot of like stuff is coming from, the vibrational therapy, light therapy, Germany. And so, as an American, I find it a little disheartening that I have to actually go out of the United States to actually do this and really be accepted. So I think that that's what's happening is that there's research that photobiomodulation is actually the equivalent of medication. Maybe that, and again, you can Google
it. It's that effective.
But the cool thing about photobiomodulation is that it has a significant reduction of actually side effects, which really there's very few side effects from photobiomodulation. So it's kind of like, is it too good to be true? And really, it goes back to really us as human beings is that we're designed to be outside in the sun. And because of commercialization, we've come indoors and now we're seeing an increase in all these disease processes. And I think that at least a part of it is actually looking at our light exposure.
Certainly. And I agree with you. I do find it, I feel like this is the kind of thing we should be on the cutting edge of, and we're not. So that is disheartening. But presumably you and the rest of your community will be able to get this kind of research that we need. I mean, I do like to be science-based, but everything starts somewhere and science is always evolving. At least that's been my experience. I'm hearing you about like it's great that you have the ability to go and do that. And that you do have some place that is allowing you to do that, to get the information that we need to bring it back to our systems. And hopefully our systems will be more accepting of it. And, it took a long time before ABA was accepted. It takes a long time before a lot of things are accepted. I do wish we were on the cutting edge of it, though. So that does make me sad.
It's interesting, is because to answer that, though, is Harvard is actually pumping out a lot of this research. Dr. Hamblin, who's actually a researcher for photobiomodulation, is publishing papers. And, the circadian rhythm biolab at Harvard is actually talking about light exposure. It's just that I don't think the public is actually becoming aware of these research papers that are coming out. Like, I'm a nerd. So I don't watch TV. I read a lot of research papers. And, when I work with DPTs, when I work with medical doctors and they kind of question me, I'm like, look, man, like, are you reading the research? Like, not from 1900s, like 2021, 2022, 2023. Like, are you reading the new stuff that's coming out, not the barbaric, 1970s stuff? And that's what you're seeing is that the research is pumping, but Harvard is pumping out a lot of research on photobiomodulation and circadian rhythms.
Well, and I think as with anything in this field, being disabilities and for me, special education, I think a lot gets moved when parents and often moms make noise, right? When they start seeing the changes in their children and they see the benefits and it is the science. But then on top of that, we do need to, as you said, have it socially accepted as well, which means people are paying attention to it. And that usually starts with families, right?
Yeah. I mean, my fire was I was on methamphetamines for 18 years and I developed I developed crazy addictions. Fortunately, they were into reading books and I would memorize everything. But, I have a personal internal passion for this. And then I had speech impediment. So I spent years just trying to say the word R and W. I mean, I couldn't say
wow.
I had to stand up in front of the class and actually kids make fun of me because I couldn't say certain words. And then I would have behavior issues where I'd go and get in trouble. Sure. I had to basically carve my name in the principal's office.
Yeah.
And, so, I feel for the demographic of patients, but it's like, not everyone can take a drug and it actually benefit that person. So what do you do with those people that are almost false, like me? And that is these people that the 20% of people that don't respond, they shouldn't just be written off. That's the demographic that I want to help. I want to help these people that society and traditional therapy is not helping out. And I want to tell these 20% that there is a way. It's just that you have to kind of change your thought process or change the way that you're, currently getting treatment or therapy. And if you make a change, then you can get a change. But if you don't make a change, you're going to get the same type of results, like insanity.
Well, and you're right about the addiction component because there is a ton of medications and even for kids who are self-medicating, they're not getting what they need. So they end up self-medicating. Do you have a light for addiction?
No, but I'm going to take that blue light is definitely something that can definitely enhance, which is, again, reducing screen times and stuff like that, getting out in the sun and sleep cycles, balancing circadian rhythm can help out with reducing addiction type of symptoms.
Excellent. Excellent. Is there anything I've missed? I mean, there's so much information in here and I know it's going to be super relevant to parents. And I suspect this will be one of those episodes people listen to multiple times, but have I missed anything?
No, I always enjoy these things. I feel like I love to do these kind of talks because I have so much knowledge in my head. So I just like to get this stuff out to parents and people. And then I would say that I think just to answer parents' questions out there, that I would highly look into primitive reflex integration. I would also highly recommend for parents to look up vagus nerve stimulation, especially kids who have constipation, anxiety, parents out there that have children that are on the spectrum that are nonverbal or speech delayed. I would highly encourage them to research trigeminal nerve stimulation. And I would also like to highlight fungal infections that I work with a lot of kids from all over the world. And every single child that I've ever worked on that was nonverbal, especially on the spectrum, has actually tested positive for ochratoxin A, which is actually a fungus that's present a lot of times in carbohydrate and also water damaged buildings.
Interesting. That's great. And I will have all that information in my show notes as well, so that if you're out for a run or driving, you can go back and look at the show notes and get them. So for the person who's listening to this and says, I need to find Dr. Daigle and I need to find his services and I need to find NeuroSage, what are the best ways to find you and your book?
Yeah, so the easiest way is just everything's all in one. So they type in drkyledaigle.com. It has like all the information to that. So that's
Okay.
one way to do that. The second thing is my private practice is called Neurosolution LC. So basically Neurosolution Lake Charles. That would get them directly to, my website. For people that want to potentially call in, so our number is +1 337 499 3162. And then on Amazon, Books a Million, Barnes and Noble, if someone types in Cracking the Code of Autism, that's one of my books. My second book is called What If You Knew? That can be found on both of those. And then I have a very active Instagram page, Dr. Kyle Daigle. Same thing with the Facebook page, and then also YouTube channel. And yeah, so but drkyledaigle.com will get you to all of this. And that's the easiest way because it's kind of a one-stop shop that has the links to NeuroSage, the links to the photobiomodulation, the red light LED panels, and then the red light and the violet light that we use in our private practices. And then I have 3 locations here in the United States. Neurosolution Center of Austin, Texas, with Dr. Brandon Crawford. Neurosolution Center of Atlanta, which is Dr. Ryan Cedarmark. And then I have Neurosolution Center of Lake Charles. So we do have 3 clinics in the United States to also kind of help out patients, but they are in the South. And then we have another facility opening up in May, Neurosolution Center of Dubai, which is going to be in the Middle East.
Oh, wow. Great. Well, that is wonderful because I'm sure there are a lot of kids out there who need your help and your information and all of this. So thank you so much for joining me. Again, I will have all that information in my show notes. So if you can't write it down now, go back to the show notes and I will have all the ways in which you can reach Dr. Daigle. Thank you so much for joining me today.
Thank you, Dana.
Thank you so much for joining me today. Please don't forget to follow this podcast so you don't miss any new episodes and leave a review when you have a chance. If there's anything you want to hear about or comment on, please go to my Facebook page, Special Ed on Special Ed, and find me there. I'll see you next time here on Special Ed on Special Ed. Have a fabulous day. The views expressed in this episode are those of the speakers at the time of the recording and do not necessarily reflect the official policy or position of any other agency, organization, employer, or company, or even that individual today.